Hey, what's up YouTube? In this video, I am not actually gonna do what I usually do in most videos. So in this video, I am gonna actually be doing exercises instead of lessons. So the exercises in this video are gonna be covering what we have already learned, and it's also gonna teach you some new things. The basic new things, but it basically just revises all the concepts that you've already learned if you've been watching my previous videos. So we've learned about input, the print statement, if statement, while loops, for loops, everything. Not everything, but we've studied a lot, right? Like we've learned about a lot of them. So basically, in this video, we're going to be doing 3 exercises that each implement those concepts. So we have the first exercise is going to. So these are these are going in like easy to hard order, or what at least I perceive as easy and hard. So like for the first exercise we're going to be doing is adding numbers. So the user will keep on entering numbers until they stop, and then we'll add those numbers. The second one is quite useful in real life too, if you want to know whether a number is a prime number or not. Then the second exercise that we're going to be doing is actually going to tell us whether or not a number is a prime number. And the third, I is capital, right? So that this third exercise is the Fibonacci sequence. So it's gonna, so we're gonna ask it. So we're gonna, so the user will actually tell Python how many numbers they want of the Fibonacci numbers. So let's say they want the first 10 numbers, then Python will give them that. So, yeah. All right. So I have actually already made a folder for special exercises, which you can, by the way, do in Visual Studio Code by going to this going to this button and creating a new folder, which I'm not going to do because I already have. And so we have add. So let's begin. So what we're gonna do here exactly is we're gonna run a while loop, and we're gonna ask the user to like enter numbers. So they'll enter one number, then another. They'll keep on adding the numbers that they want the sum of. So let's say Python asks them, what number do you want to enter? They enter 1, then they enter 2, then they enter 3, then they enter some word like done or add, right? And so then we just make Python just add all the numbers that were there before. So it sounds confusing, but you'll get the hang of it once we start doing it. So first things first, I am going to create a list called nums, in which we will be storing all of the numbers that we have to add later on. Then I'm going to make a total variable, the variable with the name total, and this variable basically just it has the value of 0 because we haven't added anything yet. So its values is just nothing, like it's just 0. So once the user starts entering numbers, we'll start adding it. And then let's make a while loop, while true, and then this is a forever loop, right? While true loops are forever loops. But then of course, to make sure that they don't run forever, we have to put a break statement in there, basically. So now let's ask the user for the input. So prompt equals to integer. So what I'm doing here is I'm gonna ask the user for an input, like enter your number here. or say add, oh, the formatting is messed up. So I'm actually going to use single quotes for the whole string, and then I'm going to put double quotes here. So enter a number here, or say add to stop and add the numbers. Okay, that's really big. I'm not trying to make this some real thing, so that's why, just for like a guide for us when we're going to be running this thing. So we ask the user an input, and then let's say they enter the number 7. Now we want to convert that number 7 into an integer. Remember, Python, if it's still a string, because all inputs are by default strings, so we have to convert them into an integer if we're going to be doing any adding, subtracting, multiplying, dividing, basically all of that. If we want to be doing that, then we have to convert it into an integer. So now let's just validate it. So if it's add, if the user has entered add, then we just stop the whole loop. But first we just print the sum. So what we're going to do is if prompt equals to, which is a comparison operator, compares. If prompt is add, then this is really simple. The user can add anything else. Like let's say user enters banana, then Python's gonna throw us an error. But we don't want to deal with that right now. We're just making it basic. So if prompt is add, then we just have to go for I in nums. So this will create a for loop, right? For I in nums. So I is the iterator and nums is the iterable. You'll know what I mean if you watched my previous video, but if you don't, then that just means that I is like an object that circles through the list nums. So for I in nums, now we have to add nums to total. So total plus equals to num. Plus equals to, plus equals to I. So basically now what this is going to do is, let's say the user enters 1, 2, and 3. Then the list nums. So actually let me create that thing here. So if the user doesn't enter add, let's say the user enters something like any number, right? Then we're gonna append that. So nums dot append integer. We'll convert that into an integer, but prompt. I actually don't want to make it converted into an integer right now, because like what if the user enters add, right? And they're gonna have to at one point. Then when Python tries converting the 3 characters add to an integer, Python's gonna throw us an error. So let's just keep this like how it is, just a string. If prompt is add, then we just add everything to the variable total and then print that variable. Print, say something to them like the sum is total, right? And else we're gonna append it. So this looks a bit confusing right now, but now when we plug in values, then let's see what's gonna happen. So let's say the user enters 1, okay? Then like the user enters 1, then the user enters 2, then 3. So the list nums, it'll have the integers 1, 2, and 3 because the user didn't enter add. So now whatever they enter, 1, 2, and 3, will be converted into an integer and it will be appended into the list nums. So now if the user enters 1, and then 2, and then 3, then nums is going to consist of those 3 integers. And then let's say the user enters add. Then for I in nums, so we're going to go into nums. So first I is going to be 1, then 2, then 3. So then we add the value of I every every iteration. We're gonna add the value of I into total, and then print the sum is, and then the sum, which is the variable total. So, so basically now let's run that and see what happens. Okay, enter your number here, or say add to stop and add the numbers. Let's say we enter 1, 2, 3, and now we enter add. So now it's gonna add 1, 2, and 3 to total and then print it. Okay, so now here's the error. It says this. It said it 3 times. The sum is 1, the sum is 3, and the sum is 6. And the while loop still didn't stop. So what we have to do now is, we don't want to put the print statement inside the for loop, because every time the for loop runs in every iteration, it's gonna print it. So once the for loop is done running, then we're gonna print it. And also we're gonna break it, because we don't want the loop to go on forever. Remember, it's a forever loop. Right? So here. All right. So let's do that again. 1, 2, 3. Now let's see if it works. Let's do add. Now it says that the sum is 6, which is what we wanted, right? And now let's go, because that's the sum of 1, 2, and 3. Now let's go and see how this works. So from the beginning, there's an empty list nums, and there's a variable called total. There's a while loop, and then the user enters, let's say 1, and then next time they enter 2 and 3. So when they enter 1, Python's like, did they enter add? No, they entered 1. So then 1 gets appended to the list nums, and then 2, and then 3. And then at the end, when the user enters add, then it goes through nums and it adds each element of the list into the variable total, and then it prints the sum is total. So that's how that worked. So actually, I think this has covered every concept that we've been over in the past videos. So yeah. Then now let's move on to the second one, which is prime. So we're gonna figure out whether or not the numbers are prime. So first things first, we just want to take whatever the number is from the user. So input. And this time we are going to do input, so that we want to convert whatever the user's input is into an integer, right? So enter the number here. Enter the number here, and while true. Let's make another while true loop, and well, not while true actually. I don't want to do while true. Let's do for loops this time. They're much easier. So for I in range, and you learned about range in the last video. So range just creates a list from one number to another number, and it's not going to include the second number. So basically, let's make it 2 and num. Now the reason I did that is because every number has at least 2 factors, even prime numbers. So let's say the number 7, it has the 2 factors 1 and 7. So 1 is always a factor of every number, and the number itself is also a factor. So like, let's say some random prime number 67, let's say 67. 67 is a prime number, and its only factors are 1 and 67. But we don't want to include those factors. We just want to see which other prime number, and non-prime number is a number which has other factors other than 1 and itself. So that's why I did 2. So it's not going to include 1. And I also did num. So that, and you know, and this is the start value, and this is the end value. And you guys know that the stop value never gets counted. So num itself will never be counted. That's how the range function works. It starts at 2 and it includes 2. So if the number is 7, then it's going to be 2, 3, 4, 5, 6. It's not going to include 7 itself. So there we go. Python just does that for us. We don't we won't include the number itself as a factor. And actually, I want to make prime is true. So we have a variable like an indicator that tells us whether the number is true or not. And by default, it's going to be true. Let's just say it doesn't matter, but just make it true. Or actually, it does matter because if it's going to be true, and if we don't change it to false, then at the end it's still going to be true. So let me show you what I mean. So prime is true, and then if so, and here's a new concept that you guys don't know about. So there's this percent thingy. It's called a modulo operator. So it's an operator that basically gets the remainder of a division. So if we do 7 divided by 3, then the remainder is 1, right? So if we do if we do like 7 modulo 3, this is gonna give us 1. So basically, if num I is 0. And so what I mean by this is, not 1, but I. Yeah, so basically what I mean by this is that if the number is divisible by I. So let's say I is 2. Okay? Let's say our number is 6 and I is 2. So if we, what's the remainder of the division 6 divided by 2? The remainder is 0. So if the remainder is 0 of any division, then we know that one number is divisible by the other. So then we're going to turn prime into false. There you go. So now it's false because we know that as soon as it has one factor that's not 1 or itself, it's not prime anymore. Nothing in the world can change it from being prime. If Python's like, is 6, we have to make Python think it like this. Is 6 divisible by 2? Yes. Then 6 is not a prime number because it has a factor other than the 1 and 6. So we're going to actually make it break. So we're going to turn prime into false and break the loop because we don't want it to go ahead. Because there's really no point. Nothing can change the fact that 6 is not a prime number, right? Once we've found a factor. And if, let's say we have our number is 7. If 2, 3, 4, 5, and 6 are not factors of 7, and in fact they actually aren't factors of 7, then prime was originally true. It never became false, so prime is still true. So if prime, and this is a little trick that I've used. It's basically just prime's value is true, right? So if prime can be written by if true, and whatever goes under if true will, remember, everything can be divided into if true, into the categories if true and if false. If true, whatever goes under if true will always run, and whatever goes under if false will never run. So if prime, so if prime is true, then print prime number. Just print prime. And then else, if prime is like false, then print not prime. So let's say prime is true, then it's gonna print prime. If prime is false, then it's gonna move on to the else statement and it's gonna print not prime. So let's enter 7. And it says that 7 is prime because it is prime. It has no factors. And let's put 100 basically. 100 is not prime because it has many factors like 2, 4, 20, 50, like stuff like that. And so it's not a prime number. And what this does is basically, essentially, this code that we've made here, it just takes the range of numbers from 2 to the number itself and sees which of these numbers can be a factor. If none of the numbers are a factor, then the number is prime. If even one of the numbers are a factor, then the number is not prime. So, yeah, that. And just one more, guys. Just hold on. I know you might get tired watching this, but there's just one exercise left. And it's if you're not familiar with the Fibonacci sequence, then it's basically a sequence where we take one number and a second number, and then the next number is the addition of those two numbers. So basically, Fibonacci would be something like this. So it starts with 1, and it keeps. Well, it can. So basically, it varies. Some people they like their Fibonacci sequences beginning with 0. It can begin with 0 or 1, and it really doesn't matter. But it basically goes like this. Yeah, so those are like the first 6 numbers. Those are the first 6 numbers. So we take 1, and then we take another 1, and the next number is the addition of 1 plus 1. The next number is the addition of the previous 2 numbers. 1 plus 2, which is 3. And then 5, and then the next number is 5 because it's the addition of 2 and 3. Then the next number is 8 because it's the addition of 5 and 3. And so it keeps on going like that. So let's make a list of actual numbers. Let's call it fibnums equals to an empty list, like the numbers of the Fibonacci sequence. And then num, let's make a num and equals to input how many numbers of the Fibonacci sequence would you like? And I have made a lot of typos, which I'm going to fix because I make a lot of typos whenever I'm typing something. So yeah, how many numbers of the Fibonacci sequence would you like? So that's how many like let's say someone wants the first 4. The user wants the first 4 numbers, so we're gonna give them that by so for I in range num. And so this, if num is 7, so let's say you want the first 7 numbers of the Fibonacci sequence, then it's gonna go from, I really doesn't even matter here. I has no significance. So I is just a counter. It counts stuff. So like it begins from 0 all the way to 6. So it goes 0, 1, 2, 3, 4, 5, 6, which is 7 times. So yeah. It doesn't matter what numbers they are. Something's gonna happen 7 times. That's what this for loop is trying to do. And then, of course, we have to make 2 variables, and I'll explain what these do. But just hang on. All right. So remember, I told you how in Fibonacci sequence, the next number is the sum of the previous 2 numbers. So in the previous 2 numbers, there's the first number, and then there's the second number. And so here, what we're gonna do is we're gonna make the sum of those 2 numbers. So let's say new is first plus second, and then we are going to, let's say, fibnums dot append new. So, and actually Fibonacci sequence in the one we're doing in our variation, it's going to begin with 1. So it goes like this: 1, 1, 2, 3, 8, 13, 21. So let's fibnums dot append new, and so this is automatically gonna append 1 because 0 plus 1 is 1, and that's the value of new. So it's going to append 1. So it's 1, comma 1 right now. 1, comma 1. That's the list, fibnums right now. So, and now what we're going to do is we're going to make the first number what the second number was. And then make, and this is getting really confusing at this point, so that's why I'm going to do some real explaining right now. So, like I showed you, let's make that thing again. I should have copied it. Right, 1, 2, 3, 5, 8, 13, 21. So these are like the first, like I think 8. Yeah, first 8 numbers of the Fibonacci sequence. First 8 digits, and no, first 8 numbers. Right. Okay. And so let's say this is the first number. So this is the first number. This is the second number, and this is the new number. Now this 2 is the first number, 3 is the second number, and 5 is the new number. Now 5 becomes the 5, which is actually 5 actually becomes 3 becomes, and this is actually really confusing. So if I want to explain it to you correctly, I'm gonna have to make it like this. So you know how the 1 is gonna be the first number, and 2 is gonna be the second number. So, and that makes 3, right? 1 plus 2 is 3. Now what's the next number? So 2, which is actually the second number, is now the first number. And 3, which is the new number, is actually now the second number. So here, we're actually just making it like the first number was actually 0, then its second number is 1. Now that makes 1. So now first is going to become second, and second is going to become 1. So it's going to be 1 and 1. And now first, and now we're going to add 1 here. Gosh, this is getting confusing. But actually, you know what I'm going to do? I'm just going to run this. So print the list. Let's just print fibnums. Things are best taught when they're best taught when I show you the. How many numbers would you like? Let's say 7. Then this is gonna show us the first. Oh no, this is showing us the first 8. So actually, we're gonna make it num minus 1 and what? Oops, sorry. Right. So we're gonna make this num minus 1 because this number 1 is always the beginning of the Fibonacci sequence that we're doing. So we're actually not gonna include. So we're not gonna include that in there because if it's always included. So if we do what numbers would be like, and we put 7 numbers in there, and there are actually 8 numbers because we're including this first number. So we're gonna make it num minus 1. So actually we're gonna generate 6 numbers of the Fibonacci sequence to mix with the first number 1 to make 7 numbers in total. So that's why I'm doing it. Now let's run this again. I would like, let's say, 10 numbers. And so as you can see, there are 10 numbers here, and they are following the Fibonacci sequence. So it's 1, which is the beginning, so yeah. And then there's the first number, 1. The second number, 2. And 1 plus 2 is 3. So now there's 3. Now 2, which is the second number, now becomes the first number. So as you can see, first is second. So right, the first number is actually becomes what was the former second. So like now 2 is the first number and 3 is the second number because 5 is the new number. Now 3 is the first number, 5 is the second number, 8 is a new number. Now 5. So like it keeps on going like that and forever. So that's why I'm like, so I put 10 here, and we can put anything we want. Let's say we can put 1,000, and I should not have done that. And we get Fibonacci numbers from like the first 1,000 numbers. So yeah, that's all I wanted to show. I'm sorry this video was so long, but I really just wanted to cover these basic concepts in Python. And so, yeah, bye-bye. See you next time in my 9th video. Bye.